Alright, so today we're going to be solving logarithmic equations. We have ln of 4x plus 1 minus ln of 3 equals 5. Now the first thing I want to talk about is the biggest mistake students tend to do. They know we have this property that says e to the ln of x equals x, which kind of sort of implies that those go away. They don't, but it kind of looks that way. It just equals the inside. So what a lot of students try to do when they get to the test and they aren't quite sure what to do, they try to make these into exponents like this. Now we are eventually going to make these into exponents, but the problem here is we have the rule to algebra that if you were solving an equation, completely different problem, x plus 5 equals 6, and you were trying to solve that, we would subtract 5, right? Now whatever you do to one side, you must do the exact same thing to the other side to keep that equality. So when I look at it here, is our equal sign goes straight here, down this, where the equal sign was. Negative 5 still equals negative 5, so that's a true algebraic statement. That does not change the truth value of this equation. But if you look at it up here, there's my equal sign. Does e minus e still equal e? No, e minus e is 0. 0 doesn't equal e. So right off the bat, this is telling us we don't have our validity still going on if we just take e's to every base. Set e's as every base. So that cannot happen. What we're going to need to do is we can only do it once to each side. Once to the left, once to the right. You cannot leave any terms out. So we still have this 5. That 5 has to be affected because you've got to do it once to the left and once to the right. What we're going to end up doing instead, we're going to compress into one log. And I tell my students, don't get rid of logs until you only have one log. There's only one log, then you can get rid of it. Now you can technically, if there's a log equals a log, but if you had any term that didn't have a log, in addition to those, you would need to make sure you only have one log. So we're going to compress these down into one log. There is a property with logs that says subtraction, well this is my version of it, subtraction on the outside means division on the inside. And I try to write that down because the more you write that down, the more you're going to remember these. The more you're going to remember that it's subtraction on the outside and division on the inside. If the division was on the outside, there's nothing we can do. If the subtraction was on the inside, there's nothing we can do. But since the subtraction is on the outside of the logs, meaning not inside of it, it is in front of a log between the two logs, that can become division on the inside the parentheses. So we're going to create one log. And I'm going to switch markers in a minute because I know it's squeaking. The first one goes on top. First inside. Subtraction sign sure does look a lot like a fraction bar, right? That's why these two tend to go together. 3 goes on bottom. So now we have it compressed into one log. We have not affected the 5 at all. So I still need to keep that 5. I have a lot of people that just try to make it go away. Don't ever lose your equal sign. We are not God. We cannot create nor destroy an equal sign. Keep your equal sign. Okay? Now that we have just one log, we're going to work on getting rid of it. Now there's actually 2 ways that we can get rid of it, and it depends on how you think about things mathematically as to how you would want to get rid of it. The way I like to get rid of it is I use exponents. And so I have this rule of thumb that says to get rid of exponents use logs. And to get rid of logs, use exponents. So I'm going to do that way first, just because that is my preferred method. Now what works in my brain is not always what works in everyone else's brain. Trust me, y'all do not want to be trapped in my brain. So I am going to show you a different method that some of my students this semester tend to like better. And we'll see. It all depends on how your brain thinks. If you're really good at memorizing, you may like the other method better. Me, I suck at memorizing. I can't even remember what my lefts and my rights are. So I like this way better. It just works better in my head. So we want to get rid of a log, right? We need the x. The x is inside of the log. In order to get the x out, we've got to get rid of the log. So I'm going to create exponents. Now this property up here, it works with logs. It's a to the log base a of x would equal x. Basically, it's saying anytime you have logs, if the base of the exponent is the same as the base of a log, the inside will be all that remains. Here, the base of an ln is e. So the base of the exponent was the same as the base of the log. ln is just log base e. It's just a log that decided it wanted more attention and decided to take over the log world. So what we're going to do here is I'm going to create exponents. And I'm going to look and say, what is my base? This is not a, it is a log, but it's not a log. This is technically ln. So I lost 1 point there because I switched my ln to a log. And the problem was it went from base e to base 10. So you've got to make sure you keep those bases. I could have left this as log base e. That would have been the same exact thing as ln. Okay? So what I'm going to do is I'm going to say my base is e. So I'm going to take an extra step so that I can clearly see what's going on. I'm going to put an e for this term and an e for that term. And then I'm going to write my previous step as an exponent. Now I want us to look at this very carefully, color-wise. Green. Does green equal green? I have E equals E. That's keeping my validity. That's keeping this a true statement. And then let's look at the other color, black. ln of 4x plus 1 divided by 3 equals 5. Is that the same thing as the previous step? Yes. So my new stuff is in green. Green equaled green, all looks good. Okay? With these, they will go away, leaving just your inside according to this property. 4x plus 1 divided by 3 equals e to the 5th. Be very careful when you're dealing with decimals. E is a decimal, it's 2.71 I think. Don't put it in your calculator right away. Wait. Because with decimals and with problems, you only want to round once per problem. So if I go ahead and put e to the 5th into my calculator, e to the 5th power, and I get 148.4131591, that's a rounded number. It is rounded to the 7th decimal place. We don't want to round yet. I still have more math I need to do. I don't want to write down 148.41 because then I've rounded it. You only want to round once per problem and only at the very, very end. So we're going to keep going. To get rid of fractions, I'm going to multiply. I'm going to multiply both sides by 3. I want you to notice, I'm using two different colors. Red equals red, right? 3 equals 3, true. And black came from the previous question. Okay. So I'm going to erase this real quick so I have some more room to work. Those reduce away. I'm left with 4x plus 1 equals 3e to the 5th power. Okay, notice I have not yet done anything calculator-wise with that e. I'm leaving it there. I'm treating it just like I would a pi, or just like I would an x. My goal here is to solve for x. So I want to get x alone. So I'm going to keep solving. Now we have 4x equals 3e to the 5th minus 1. I want you to notice again, red equaled red. You take that equal sign, -1 equal -1. Making sure every single time I do anything, I'm keeping that truth validity. Okay, and last but certainly not least, we're solving for x. 4 equals 4. X equals 3e to the 5th minus 1 divided by 4. Now if you want, you can break that fraction up into 2 pieces. That's allowed. Or you can just go ahead and type it into the calculator like this. It is very important though that you understand how your calculator thinks. Sometimes in middle school, junior high, high school, whatever stage they start introducing the TI graphing calculators to us, they teach us all the shortcuts, which is fine and dandy, except for if you don't understand how the numbers actually work, you don't understand how the calculator actually thinks. So when we look at this, we need it to do the numerator before it does the division. So if I just type it in with no parentheses, it's going to get it wrong. It's going to do the math wrong because it's not understanding what we're telling it. When you type in fractions, you have to do it in one of 2 ways. The way I suggest anytime you type fractions in, you put parentheses around any piece with more than 1 term. So we had 2 terms in the numerator, put parentheses around that. So then you can type in open parentheses, 3e, which is second ln, to the 5th power, get out of your exponent, minus 1, close parentheses, divided by 4. X equals 111.0, I think they normally do 4 decimal places, 599. 111.0599 would be your x. The other way you can do it is you could do the numerator equals and press enter. And then because the denominator only has 1 term, divided by 4. But make sure you're not rounding as you're doing these steps. Okay? So this is method 1. Use the exponents, turn the logs into exponents to eliminate them. Make the base of your exponent the same as the base of your log. So that's method number 1. Okay. Method number 2, I'm going to come back to this step. Very beginning. You've still got to compress the logs. We've still got to get one single log. You're not going to get rid of logs when you have a million logs all over the place. And what this method is going to rely on is that you memorized your formulas really well for logs versus exponentials. We have a formula that says y equals log base a of x, and that is the same thing as x equals a to the y power. If you're really good at memorizing, that may be a better method for you to use. Could work. So what we're going to do here, we're going to look at this, and we're going to say, okay, we have that one, right? It has a log. Log is just a fancy way of saying ln base e. So this is really log base e. Okay. So I want to start by saying what is y, what is a, and what is x. I don't want to do that in my head because I have actual x's, right? I may have y's, I could have all sorts of a's, I could have all sorts of letters. So I want to write down from my formula what those pieces are. So y is always what the log is equal to. Log is equal to 5. My a, that's the base of my log. Well, here I have ln, or log base e. And my x, that's my inside. So my inside here is 4x plus 1 divided by 3. And what we're going to do is we're going to take this information and we're going to rewrite it in this form. So x, that's 4x plus 1 divided by 3 equals a, that's an e, to the power of did is that first step where we raised everything into exponents and reduced away the ln and the e, it just took that first step for us. So it all depends. Would you rather do it with exponents or with formulas? Some people are really good at memorizing formulas. They tend to really like this one better. Some people have a really hard time of memorizing formulas, so they tend to like the exponents better. You can use either way. From here, you would multiply both sides by 3. Subtract 1. And divide by 4. Then type it into your calculator to get the exact same answer. Okay. Whichever method you want to use works, as long as it's done correctly. Remember, you don't want to do e minus e equals e. That will not work. New has to equal new.